In this video I have a few different examples of horizontal centripetal force, and we're not really going to be solving anything for these three examples. We're really just going to be taking a look at what's happening to the objects in these examples and why they're moving in a circular motion. So the first one is this car making a fast left-hand turn. The front passenger is not wearing her seatbelt. Well, what's going to happen is, if this is the car, and if it's going straight originally, let's say the passenger is just sitting here on the right-hand side of the car in the front seat. What's happening then is, as the car keeps moving left, so in the middle of the turn, as the car is moving left, the car is changing position. The passenger is forced to change position. And what's causing the passenger to change that position ends up being the door of the car. It would be her seatbelt. Her seatbelt could hold her in place if she were wearing her seatbelt, and that would cause her to turn left, but it's the door in this case. Some of you have probably experienced this when you're driving in a car. If you don't have, let's say, a seatbelt on, if you make a left, you can feel yourself sliding to the right. If you make a right, you can feel yourself sliding to the left. And the reason why that is it's your inertia. It's your body's inertia that's trying to carry you forward. It's trying to keep moving you in the same direction of motion that you were already moving in. So if you're right here, you want to keep going straight, but you can't keep going straight because the car's door is pushing on you, and the car's door is an inward force that's keeping you moving in a circle. So it's actually the door in the car in this case that's causing that circular motion on the passenger. For the second one, we have a washing machine in the spin cycle. And the washing machine in the spin cycle, the clothes are kept in a circular motion because of the walls of the washing machine. So if these are the walls of the washing machine, you've got the clothes that are basically, they're pressing up against the wall because they want to keep moving forward. It's their inertia that's keeping them forward, but it's the wall of the washing machine pushing the clothes inward. That's actually how a spin cycle works, and that's why they have the spin cycle. Is if you ever look at the inside of a washing machine, they have the little holes in the side of the washing machine. Those little holes allow the water to pass through, but the holes are so small that the clothes aren't going to be able to pass through themselves. So when the washing machine spins at a high rate, the clothes themselves are going to be pushed against the wall because its inertia is basically carrying the clothes. The inertia of the clothes are carrying the clothes against the wall. The water also wants to keep moving forward too because of its inertia, but the water can pass through the holes, and so the water goes through the holes of the washing machine, which causes the clothes to dry out. So a lot of that water escapes, and that's what takes a lot of the water out of the machine, so that way you can move the clothes into the dryer and the clothes are relatively dry compared to how they were while they were washing. So that's really what the whole point of that spin cycle is. And then the last one we have is the gravitron at a carnival. I don't know how many of you have been to a carnival and been on the gravitron. It's kind of like the Cajun cliffhanger at Six Flags before it closed several years ago. And what happens is, when you stand in the Cajun cliffhanger, or if you actually stand in the gravitron at a carnival, the ride spins really fast, and the floor, at least in the Cajun cliffhanger, the floor would actually sink down, but you would stay stuck to the wall. You would not move at all. In the gravitron at the carnival, usually it's angled a little bit more upwards, and there's padding. So if you lay on the padding slides up the wall a little bit as it keeps moving in that motion. In this case, it's very similar to the previous two, where it's just the wall. So it's the wall of the machine that's keeping you in place. So it's the wall that's keeping you in that circular path. So in this case, if this is the circular motion, the walls are inwards, causing that inward force which keeps you moving in the circle. If the walls weren't there, you just fly. You just keep going in a straight path because of your inertia, but the walls are keeping you in place.